Yeah, hello. I'd like to discuss this new subject about polynomial solutions. And in this case, I'd like to show you a way of solving higher order polynomials, so higher than 4. Polynomials of the order of 4 can be analytically solved. Polynomials higher than 4 cannot be analytically solved, as far as I understood. But there is a way to treat solutions and to express them in relatively simple, solvable way to do so. I have it here back on my screen, so I will show you in a moment. Let's go to the screen, and this is actually the way. What you have here, the purple one, is the one which has no, this is the x-axis, y-axis, and this one has only 1 and 2, 3 real solutions, and the rest of the solutions, it's not crossing the x-line somewhere else in these, but only here and there. But what you can do, and that's what you see here, is add a parabolically equation which crosses the higher order polynomial in several different points. And what you can do then is subtract from the higher order polynomial the parabola in such a way that it gains 1, 2, 3, 4, 5, 6, 7 0 points. And because since you know this one, you can calculate this one, and you have the 0 points of this one, which is approximately here and there. And then you can subtract this from this one, which you already know, but not have 0 points of it. You have just a general formula. But you can subtract the parabola, so in which case you get the higher order polynomial minus the parabola, in which it gains 0 points, it gets 0 points, and you can calculate these 0 points with the method I showed you earlier, which is with this, in this way. I'll enlarge the picture for you a bit. I showed you this method before. Well, let's zoom out a little, in which you have the polynomial, in this case the reduced polynomial. So here you reduce it to with the parabola formula. You know this one. This has 2 real solutions here and here somewhere. You subtract it, then you gain. You find out the 0 points of the higher order polynomial by the method I showed you before. In approaching with a parabola. This for this one, the green one here for this point. For, let's see, this point you have this purple one, yeah, the inner purple one. The other point here is with this blue line here, this blue line here. For this point you have the orange one. For this point you have this bluish one. Yeah, it's kind of bluish. For this point you have this greenish one. And then you have the 0 points of a reduced higher order polynomial. And you can reconstruct the whole thing by getting it done here. You see the reconstruction of it here. And in order to show it clearly, I added a number, but that number also can be 0, and so you don't see the difference at all. So here I reconstructed the whole thing. So you have the reduced polynomial. This is the original polynomial, this one, without real 0 points. Then you reduce it with the parabola formula so that you get this one with 0 points. Then you calculate the 0 points, you find the 0 points, and then you do the whole thing backwards. This is the finding of the 0 points, and then you reconstruct it back to this one. And here I took a 0 to make a difference, so here you can see that I found it. And then it's the same formula, but I added, in this case, 100 and so you can see the difference. But if I add a 0, then they are the same. Then you cannot see the difference. So this is a way of nonetheless finding 0 points in where there are no 0 points, because you construct the 0 points in this way by having a higher order polynomial with no 0 points, and you subtract a parabola, preferably a parabola. Why? Because you can because the higher order polynomial is mostly bent or mostly flipping around. So with a parabola you can, or a third order cubic function, but the cubic function has the disadvantage that you have to do more effort to find the 0 points. It's of course you can solve a cubic function in an exact way, but it takes more effort than a parabola. A parabola is the simple ABC formula, and that's it. But for a cubic function you have a little bit more effort, so I prefer to use a parabola to create 0 points in the higher order parabola, a higher order function, a polynomial, reduce it, find the 0 points, and then adding back up the parabola again, and then that's the whole exercise. Okay, this is what I wanted to show you. It turned out that it works. I have then, of course, a higher order polynomial which has no real solutions. You have imaginary solutions, which is in itself fine. I mean, you can still use it, but why do imaginary points if you can use a higher order polynomial with 0 points and then adding or subtracting a parabola? So you have all 0 points and you don't need imaginary numbers for that matter. You have a higher order polynomial with some 0 points and you add up or subtract a parabola, and then you have the solutions as well. Okay, this is what I want to show you. I hope you understand what I mean. If you don't, then please ask me some questions about it. For hey, what do you mean? But it's all, and then I can explain it more clearly if you don't understand it. It's pretty simple. The principle is very simple, and I hope it works for you. And in this case, you can also solve higher order polynomials higher than 4 without real 0 points and with imaginary points. Okay, this is what I want to show you. Thanks for watching and see you next time. Hasta la vista. Bye.